All right, so this is going to be going over some examples for section 3.5, and then I went over this in the last video, but I want to just go ahead and write it down. So for horizontal asymptotes, you have these certain guidelines. And basically, if the degree up top in the numerator is less than the degree in the denominator for the leading terms, then y equals 0 is the horizontal asymptote, which means the infinite limit is 0. If the degrees are the same, n equals n, then you have the coefficients of the leading term. Y equals a over b is the horizontal asymptote, which translates into the infinite limit being a over b. If the degree in the numerator is more than the degree in the denominator, then there's no horizontal asymptote. It's not bounded by some finite value, which means that the infinite limit could be infinity or it could be negative infinity since it's unbounded. All right, so that's going to be crucial. I'll be referencing this in the examples. And so I'm going to start out with example 11. And they say find limit as x approaches infinity of h of x, where f of x is 5x cubed minus 3. And you have three cases. And if you notice that the cases only differ by what you're dividing by for the denominator. Case A is dividing by x squared. Part B is divided by x cubed, and part C is divided by x to the fourth. And depending on the degree on the denominator is going to dictate which of these guidelines it's going to follow or fall under. So for A, so I'll do this off to the side. So part A is doing the function that they're given. Sorry. So we're finding limit of h of x, and h of x is told to be the function f of x divided by x squared, right? Because that's what they tell us. All right, f of x is 5x cubed minus 3. So if we're doing the limit x approaches infinity of 5x cubed minus 3 over x squared. And it was 5x cubed minus 3. So for the guidelines, we have the degree in the numerator is 3, degree in the denominator is 2. So we're falling into the third category because the m is greater than n. So in this case, our degree in the numerator is 3, m is 3. Degree in the denominator is 2. So since m is greater than n, there's going to be no horizontal asymptote, which means the limit's going to be, it's unbounded, so the limit is unbounded. It's going to either go to positive infinity or negative infinity. All right, now because x is approaching positive infinity, so they tell us x approaches positive infinity. Since x approaches positive infinity, it's going to be a really big positive number. And I look at each case. So for the numerator, 5x cubed minus 3. So you're taking a really big positive number, you're cubing it, timesing it by 5, and then the subtracting 3 doesn't, I mean, it's so big that it's almost doesn't matter part of the subtracting 3 part, because of the dominant term being 5x cubed. So this is going to be really big positive number. So will be a really big positive number. The denominator is x squared. So that's also going to be a really big positive number. And so you're having a positive number divided by a positive number. That's going to be another positive number. So limit x goes to infinity, 5x cubed minus 3 over x squared. I just said the numerator is going to be a really big positive number. And the denominator is also going to be a big positive number. And it just keeps going bigger and bigger as x gets bigger. So that's going to result in a big positive number, which just essentially I'm just saying it's infinity. Numerator is more than the, or value in the numerator is more than the value in the denominator because of the x cubed versus the x squared. So it's going to be another, going to keep getting bigger, and it's positive. So the limit is positive infinity. That's the answer for part A. Hopefully that logic makes somewhat sense. And again, so part A was h of x being f of x divided by x squared. I just wrote f of x as 5x cubed minus 3 divided by x squared, and then I looked at the degrees, and the degree in the numerator is more than the degree in the denominator, which means it's unbounded for the limit as x approaches infinity. So it's either going to be unbounded to positive infinity or negative infinity. And so I just thought of it just logically, like, well, if x is a big positive number, then 5x cubed minus 3 is a big positive number. X squared is also a big positive number. But the numerator is bigger than the denominator, so it's just a bigger positive number divided by another big positive number results in a positive number. So it's unbounded to positive infinity. Now for part B, same kind of thing for part B as far as you're just dividing by x cubed now. So now do 11b. Taking, so h of x equal to f of x divided by x cubed for part B. Okay, x cubed, or f of x is the 5x cubed minus 3. And notice the degrees are the same. So m is 3, n is 3. So degrees match. And that makes us in the category 2. It's just the ratio of the coefficients, like y equals a over b is a horizontal asymptote. In this case, technically it's like 1x cubed, so you do 5 over 1, which is 5. So y equals 5 is the horizontal asymptote, which means the infinite limit's going to be 5. All right, that's the answer for part B. Now part C, instead of dividing by x cubed, you'd be dividing by x to the 4th power. Okay, so 5x cubed minus 3 divided by x to the 4th. All right, so this time we have the numerator has exponents 3 to the m is equal to 3. The n is 4. So in this case, the degree up top, m, is less than the degree on the bottom, which puts us in the first category. M less than n, y equals 0 is the horizontal asymptote, which means the infinite limit is 0. All right, so that shows you the different scenarios. Again, part A, we had the numerator having a bigger degree than the denominator, so that gave us an unbounded behavior to the graph, which gave us no horizontal asymptote, and then we deduced that it had to be positive infinity. And then part B, it turned out to be the same values for the degrees and gave us 5 for the answer, since that's the ratio of the coefficients. And then part C, the degree in the denominator was bigger than the degree in the numerator. So since m is less than n, it's always y equals 0 for the horizontal asymptote. So that's the infinite limit is 0. All right, so it's very crucial to know this in green. That's where I'm basing a lot of my decisions, pretty much all of my decisions, based off of what's in green. All right, so these are some other limits. So number 17. All right, so you can distribute limits. So you could say this is the limit x approaches infinity of 4 plus doing the limit as 3 over x. So we know that for 4, there's no value for x you're plugging in, so it's always just going to be 4. Now for the 3 over x, you can think of it as I have just a constant in the numerator. A constant has degree 0. Right, because you could say 3 is the same thing as 3x to the 0. X to the 0 is 1. So that's really like 3 times 1, which is 3. So any constant has a degree 0. So we have in the numerator, m is 0. X in the bottom, so that's like x to the first power. N is 1. And so since m is less than n, then that means for 3 over x has the y equals 0 as an asymptote. Right, the degree up top is less than the degree on the bottom. That means that infinite limit is going to be 0. So this is 0. So I have 4 plus 0. All right, and anytime you have a constant, the degree is always 0. And from the previous video, there was actually a theorem. The theorem stated that if you had limit x goes to infinity and it's some constant divided by x to the r, that's going to be 0. All right, that's a specific case, and I just think of it as just in general terms, like what's in green, following the same sort of guidelines. It's just anytime you have just a constant or just a number as your whole portion for the top or bottom, that means the degree is going to be 0. So since it's 0 for the top and then 1 for the degree on the bottom, that piece 3 over x has y equals 0 as the asymptote. All right, so that's that one. And now number 21. Okay, so again, just focus on the leading terms, and the leading term for the numerator that has a degree, m is 2, and the denominator has the leading term, 6x cubed, has the exponent 3, so the degree n is 3. So m is less than n. Degree up top is less than degree on the bottom. That means we have, again, y equals 0 as the horizontal asymptote. All right, so that's the limit. Infinite limit is going to be 0. So the answer the limit is 0, since that's what the horizontal asymptote is. So even though it says x approaches negative infinity, it doesn't matter. It's still going to give you 0 because of the fact that the denominator has a higher degree than the numerator. All right, the next one's number 23. All right, so x approaches negative infinity, and we have 5x cubed divided by x plus 3. Focusing on the leading term, so the degree up top, m, is 2. And then x is the same thing as x to the first power, so n is 1. In this case, degree in the numerator is more than degree in the denominator. So m is greater than n. That means there's no horizontal asymptote, so it's unbounded. Now the limit's either going to be unbounded to positive infinity or negative infinity. And I sort of just look at each thing separately as far as the numerator and denominator. So 5x squared, that's going to be positive, since squaring a negative number is positive. So whatever the negative number is, it could be big, really big negative number, it's just going to result in a big positive number since I'm squaring it for the 5x squared part. All right, so at least I know the top part's positive. Now the denominator, x plus 3. So if I plug in a really big negative number in for x, like negative 1,000 for instance, and you add 3, it's still going to be a negative number, really big negative number. So this is going to be a really big negative number. So that's going to be negative if x is negative. So for the limit, x approaches negative infinity of 5x squared over x plus 3. We know it's going to be a positive number up top because of the square. And then it's going to be divided by a negative number in the bottom. The positive divided by negative is negative. So that's going to be negative. All right, because positive divided by negative is negative. So this is going to be negative infinity is the answer. Again, we looked at the numerator has degree of 2. The degree on the bottom is 1, so the degree on the numerator is more than the degree in the denominator, which means it falls into the category 3 in our guidelines. There's no horizontal asymptote, so it's unbounded. So it's either going to go to positive infinity or negative infinity. And so I just deduced it being negative infinity because the numerator is 5x squared. Plugging in a big negative number in for x squared results in a positive because squaring a negative number is positive. So 5x squared is positive, and then x plus 3 is negative. So you have a positive divided by a negative, which gives you negative. So the overall limit as x goes to negative infinity is going to be negative infinity. All right, so that's the answer for that one. And notice there wasn't much algebra going on here. It's just looking at this pattern of degrees. Now 25 is going to be the difficult one. So this one's difficult because well, for one thing, I have a square root in the denominator. And all the other questions I've done, I haven't had a square root. And so that's something that's different. They do say, they give you a hint. And I'm going to follow example 4b. So I won't do the example 4b. I'll just kind of do the similar steps on page 203. And then since x is going to negative infinity, x is going to be less than 0. And so if whenever you have for x less than 0, you can write x as a negative square root of x squared. All right, because we know the square root of x squared is x, and so you have negative times x, but x itself is negative, so that way it's a negative times a negative makes positive. All right, so this is what we're going to do. We're going to use this in combination of following example 4b. And what they do in example 4b is they go ahead and divide numerator and denominator both by x. So first, divide by x to the numerator and denominator. Okay, and right now I'll just focus on the fraction itself. So I'll worry about doing the limit at the end. So I'm going to focus on simplifying this. So I divide top and bottom by x. So up top is going to be x divided by x. And on the bottom it's going to be the square root of x squared minus x divided by x. Well, I know x divided by x is 1, so this is going to equal 1 up top. And here, I'm letting x be the negative square root of x squared. So I'm going to substitute that in for x. So for the bottom, it's going to be square root of x squared minus x divided by negative square root of x squared. And that's using that because x is less than 0, since our limit is going to negative infinity. All right, so I'm going to go ahead and put this minus sign up top with the 1, so I have negative 1. And then I have a square root divided by a square root. You can combine that into one square root. So I can combine it, so it's x squared minus x divided by x squared under one square root sign. And again, I just put the minus sign up top. That's just a preference thing. And now I'm focusing on simplifying the denominator, and I combined it into one square root. And so I'm going to end up dividing x squared by x squared and then x divided by x squared. So I have x squared divided by x squared and then minus x divided by x squared. So that's going to equal minus 1 divided by the square root. X squared divided by x squared is 1. And then minus x divided by x squared, that's 1 over x. All right, that's as far as I can go with the simplifying. Now I'm going to apply the limit. So we did all this simplifying so that we rewrote the problem. So originally we had limit x goes to negative infinity of x over the square root of x squared minus x. That's what we started with in the beginning. And then I did some simplifying. I pretty much followed example 4b on page 2 or 3. These are the steps they do. And I use this hint where for x less than 0, you use x equals negative square root of x squared. And since x is approaching negative infinity for our limit, x is going to be negative. So we did the simplifying. We got this to be negative 1 divided by the square root of 1 minus 1 over x. Okay, so then I can apply the limit. And you could apply the limit to each piece. So negative 1, and then divided by a limit. Which is negative infinity of the square root of 1 minus 1 over x. Well, the top's just negative 1 since there's no value which we're plugging in for x, so that's negative 1. And for the bottom part, I'm going to apply the limit inside of the square root sign. So you do the square root of the limit x squared is negative infinity of 1 minus 1 over x. All right, and if I just focus on the 1 over x part, so the degree up top, so this is a constant, 1's a constant, so the degree is 0. So we have m is 0, and on the bottom we have x, and that's x to the first, so we have n equals 1. So the degree up top, m, is less than the degree on the bottom, n. So what does that mean? So that means we have y equals 0 is the horizontal asymptote, which in other words just means that that limit 1 over x is 0. All right, so combining this with what we have, this part is 0. So I'm going to have equal to negative 1 divided by the square root, and then the limit x goes to infinity, negative infinity of 1 is just 1, so that's just going to be 1, then minus, and then the 1 over x part is 0 as x goes to negative infinity. So I have negative 1 divided by the square root of 1, which is going to give me negative 1. All right, so that's going to be our answer. All right, so that's the hardest one because it had a square root sign. And just to recap real quick. So I followed example 4b on page 203, and I'm using the hint x is going to be negative square root of x squared. The first step we do is divide by x from top and bottom. Up top is x divided by x, which is 1. On the bottom, it was the square root of x squared minus x divided by x. Then I just substituted negative square root of x squared in for x for the bottom part. And so I combined the bottom part into one square root, since you can do that. And I put the minus sign up top with the 1. So that way I don't get a bunch of minus signs mixed up on the bottom. So I put that up top, so it's minus 1 up top. And so I had the square root of x squared minus x over x squared. And then I just separated that into two fractions where I have x squared over x squared and x over x squared. Well, x squared over x squared is 1, and then x over x squared is 1 over x. So that's what it came out to be simplified. So I just rewrote the problem into that simplified version, applied the limit. You apply the limit to the top and bottom, so that's why I put limit to the top and then limit to the bottom. Well, the limit of the top part is just negative 1 since there's no value variable x. On the bottom part with the square root sign, you can distribute the limit inside of the square root. So you're taking the square root of the limit. All right, and then that 1 minus 1 over x part is what I'm taking the limit of. Well, the limit of 1 is 1. Now the 1 over x, that's going to be 0 as x approaches negative infinity because of the fact that 1 over x, 1 is a constant, got a degree of 0, and on the bottom x has n equals 1, so the degree up top, 0, is less than the degree on the bottom, 1, which makes y equals 0 the horizontal asymptote, which will mean that that limit 1 over x as x approaches negative infinity is 0. So that's why I have this 0 right here. So that gave me my answer, negative 1. Next video, I'll start out with an example just like this one, like number 25. All right, so that's where I'll stop it for this video.